This is a senior design project for the Spring 2018 Engineering Capstone at Oklahoma State University Institute of Technology. This project uses two separate systems manufactured by the Festo Corporation, the Festo MPS Distribution Station, which is shown on the left, and the Festo MPS Sorting Station, which is shown on the right. The primary function of the distribution station is to separate individual workpieces, which we have a red and black composite material and a silver aluminum material. It separates them out of a stack of workpieces to transfer or distribute them. In this case, it's to the sorting station. The primary function of the sorting station is to separate the workpieces into rows based on their color or material. For this project, the two stations are going to be combined into a single integrated automated control system using the Siemens S7-1200 PLC. The Siemens PLC is interfaced to an assortment of electrical, mechanical, and pneumatic devices to monitor and control the automation process. A Siemens 7-inch HMI panel is also used to provide additional control options and to provide a visual representation of system operation. The electrical system is powered by a 24-volt DC power supply right here, which is used to power the PLC, the HMI, and terminal blocks for all the input and output devices of the distribution station and the input and output devices of the sorting station. The pneumatic system is powered by a 110 psi air supply from an external air compressor. The air supply feeds into two separate filter regulators, one for the distribution side and one for the sorting side. The primary function of the filter regulator is to prevent contaminating particles from entering into any of the pneumatic lines, which could cause issue with the pneumatic devices. And it also regulates the air supply pressure down to 60 psi, which is the desired operating pressure for the Festo pneumatic components. The filter regulator feeds into a control valve manifold, one on the distribution side, one on the sorting side. The control valve manifold uses electrical signals sent by the PLC to open and close valves for different actuators and pneumatic components within the system. The first stage of the automation system is the distribution station. It consists of a stack magazine, which is a stack of work pieces, a vertical stack which creates a magazine of work pieces, and the stack magazine module, which is the whole assembly right here. It consists of a pneumatic dual-acting cylinder under here, which will either retract and push the workpieces out of the magazine stack, or extend, allowing the next workpiece to fall down into position. The dual-acting cylinder has inductive proximity sensors on each side, which will tell the PLC and verify that there's been full extension or full retraction. We also right here have two different fiber optic through beam sensors, which will detect the presence of a workpiece once the cylinder has been retracted and push the workpiece out into ready position. There's also a through beam sensor in the barrel of the stack magazine, which verifies that there is a workpiece in position ready to be ejected out into the system. There's also the changer module right here, which consists of a pneumatic rotary drive on the back side, which uses pneumatic signals to move the rotary drive either clockwise or counterclockwise. There are micro switches on each side of the rotary drive module, which are adjustable, and they limit and monitor the travel of the changer arm. The changer arm has a suction cup which is connected to the vacuum module on the control valve, which is used to pick up and secure the work pieces so they can be moved from one station to another. Now we have the sorting center of the automation process. We have the conveyor belt assembly, which is powered by a 24-volt DC motor. There are various sensors. We have two different diffuse sensors on here, which are adjusted independently. The first diffuse sensor is adjusted with a very low sensitivity to where it will detect any reflection of light from the red, black, or silver workpieces. This sensor is used to establish that a workpiece is on the conveyor belt. The second diffuse sensor over here is adjusted with a much greater sensitivity to where it will not detect the black colored workpiece. It will not detect the light reflected from the black colored workpiece. We also have an inductive sensor which is used to detect the metallic workpieces and differentiate them from the composite workpieces. We have two pneumatic actuators that are used to move these separator arms and divert the workpieces down into each one of these separator slots. There's a retroreflective sensor that goes across the slots, and that is used to detect when a workpiece travels down the slot or if the slot is at max capacity. The first step of the process is to activate the system using the Start push button. Once the system is activated, the through-beam sensor in the magazine barrel will detect the presence of a workpiece. If the beam of light is broken, it will create a normally closed contact, which the PLC will read as a digital high input. Once the PLC establishes that a workpiece is in position and ready to be ejected, it will send a digital output to the control valve manifold, which will open the valve and send a pneumatic signal to the dual-acting cylinder, which will retract the cylinder and eject the workpiece into ready position. Inductive proximity sensors on the dual-acting cylinder will verify that the cylinder has reached full retraction, and the fiber optic sensors will also read that a workpiece is present and in the ready position. Once the PLC verifies that these two actions have taken place, then it will extend the cylinder back into ready position. Once the inductive proximity sensor has established that the cylinder has been retracted back to ready position and establishes that the fiber optic sensors are reading a workpiece, it will send a output to the control valve manifold, which will open and send a pneumatic signal to the rotary drive of the changer module. It will provide a pneumatic signal to move the changer module arm into the position of the workpiece, and at the same time it will activate the vacuum module at the control valve manifold, which will provide vacuum in the suction cup, which will allow the workpiece to be firmly attached so it can move from the changer module to the conveyor module. Micro switches on the back of the rotary drive module will verify that the changer module arm has moved into the position of the workpiece, and at that point the PLC will remove the output signal from the control valve manifold. Once it establishes that it's in position of the workpiece and has made contact, it will provide another output to the opposite side of the rotary drive module, which will move the arm back into the position of the conveyor belt. Once the puck is on the conveyor belt, the first diffuse sensor will verify that the puck is present, and that will tell the PLC to remove the output from the vacuum module, which will release the puck onto the conveyor belt. At the same time, the PLC will provide an output to the conveyor belt motor, which will activate it and cause the workpiece to start moving down the conveyor belt. These two sensors, the second diffuse sensor will establish whether the workpiece is red or silver. Based off of, it will create a digital high input if it's red or silver based off the reflective properties, and the black workpiece will create a digital low. The second inductive sensor will establish if the workpiece is a metallic, a silver workpiece, or if it is a composite, a black or red workpiece. If you get a digital high from the first diffuse sensor, that will tell you that it's either silver or red. And if you get a digital high from the inductive sensor, that will tell you that it's a silver workpiece, in which case this first actuator will move the separator arm and divert the workpiece down into this first separator slot. If you receive a digital high from the diffuse sensor and a low from the inductive sensor, then it will tell you that it's a red workpiece, in which the second actuator will divert the workpiece into the second slot. If you get a low on the first one, which tells you it's a black workpiece, and a low on the inductive, which tells you that it's a composite, then it will travel the length of the conveyor and move down into the separator slot. The retroreflective sensor is used in conjunction with the different actuators. If the first actuator is activated and the retroreflective detects a workpiece, then it will increment the count of the silver workpiece by 1. If the second actuator is activated and the retroreflective sensor senses that a workpiece has traveled down the slot, then it will increment the count of the red workpiece by 1. If neither actuator is activated and the retroreflective sensor detects a workpiece, then it will increment the count of the black workpiece by 1. Right now it is in manual mode. Every time it goes through a complete cycle, you'll have to push the manual start button once again to create the next round. We have a few trouble modes built into the program. If the suction cup module does not pick up the puck, does not create good contact, it will return back to the original position and perform a retry picking up the puck. It will illuminate the retry indicator, letting you know that it's making a second attempt. Another trouble mode we have built in is in case the changer module drops a workpiece in transition. It will eject a new workpiece and the dropped indicator will become illuminated. Now we'll switch from manual to automatic mode, in which the process will be sped up. Once the workpiece hits the conveyor belt assembly, the next workpiece will be pushed out into position, which doubles the speed of the process. The HMI screen provides a visual representation of the number of workpieces in each of the separator slots, as well as giving a visual representation of the changer module arm movement. Right now we have 4 workpieces in each of the separator slots. We'll just increment it by 1, which you have a total count there of 13, in which now we have 5 in the first slot and 4 in the next 2. Once the separator slots are filled with 5 workpieces each, the system will be disabled and the full light will be illuminated. We will have to press the counter reset and reload the magazine barrel and reactivate the system for the next round of sorting. This has been a demonstration of the 2018 Engineering Capstone project here at the Oklahoma State University Institute of Technology.